Hello students, in this session let us continue discussion with the aspects related to the rails, which includes the failures in the rail sections and the joints that are provided to connect the rail sections. What you have to see, rail failures are generally occurs because of the defects in the manufacture during the manufacture of the rails. So in Indian railways, such manufacturing defect failures can be occur in the one or more of the following forms, so which includes that can be of the crushed head, square or angular breaks, split heads, split up, horizontal fissure, transverse fissure, flowing of metal head, and the horizontal cracks. The picture here will show you the various failures that are occurred because of the manufacturing defects. So anyways, we'll first look into how exactly these failures looks, and then we'll come back to this picture once again after the completing discussion regarding the rail, which will summarize all type of fissures, failures in the rail section. So first one is the split head. So in the head direction, we can see the splits that will occur in the head portion. And next one, the split web. On the web section, you can see the cracks that will appear in the web portion. So that can be in the horizontal direction as well as in the transverse direction, that can occur in the any direction. Then the horizontal cracks. So these are all the cracks that occurs in the horizontal direction along the length of your rail section. And the next one is the square break. So square break that will start from the head and it will go up to the entire rail section. Crush head, so wherever the crush head get crushed, so the portion of the head that gets depressed here. And the last one, the split head. I think we have covered almost all the types of the failures in the one single picture. So the first failures what we have is the crush head. So here has the name indicate your head portions get crushed. Okay, so the crushed heads are those in which we will have the either the sagged or the flattened head. So as you can see here, the head portion get sagged. So that second failure is the angular break or the square break. So you can see in the rails may get completely broken either in the vertical plane or that can also be in the angular plane. And the next in the split head, so here the head portion, the cracks occur in the middle of the head or pieces are split from the side to the end of the head. So such defects, such cracks, we call it as the split head. So next one is the split web. So this defect is the particularly occurs in the web portion of the rail section. So the cracks in the web will occur, so though this is not necessary to run through the bolt holes. The next defect is the horizontal fissure. So these are developed in the railhead, which are more common in the form of the fractures which developed gradually in the horizontal direction of the rail section. And the next defect we have it as the transverse fissure. So these are also the cross wire cracks which start from the point inside the edge and it splits like a contour shape gradually on the broken surface will look smooth oval and rounded bright spot will be visible for you in the fractured surface. And the last one is the flowing of metal heads. So metal head is forced to flow on the sides due to which the rail ends get widened and depressed. So all these failures are mainly because of the defects in the manufacturing process. So here this picture here will shows you how the transverse fissures or the fissures will occurs in the transverse direction, whereas the horizontal fissures though runs in the horizontal direction. So transverse fissures occur in the vertical direction of your rail section. The next important topic with respect to the rails is the joints in the rails. So we have already come across this word. What are all these joints? First, what is the necessary of providing the joints? The first and foremost necessary is to hold together the adjoining ends of the rails in the correct position. So both in terms of the horizontal as well as in the vertical plane. So when you provide the joints, we have already discussed this when the joints are provided. These are only two different rail sections. by providing the joints, two rail section can be connected together. So when you connect the two rail section, it should be ensured that these two are in the same plane, both in the horizontal as well as in the vertical direction. And always the joints are the weakest part in the railway track, and it has been seen that the strength at this particular joint portion is only the 50% of the strength on the parent rail section. Now we'll look into the what are the requirements of an ideal joint. So an ideal joint must provide the same strength and the stiffness as a parent rail. The characteristics of ideal joints are summarized as follows. The first requirement is the holding the rails ends together. So as I already mentioned you together, ideal joint should hold both the rails ends in their precise location in the horizontal as well as in the vertical plane, so that there will be a continuity in the track can be provided. So this helps in avoiding the wheel jumping or in the deviations of the wheel in its normal path of the movement. And also the whatever the joints we provide, that should have a same strength and stiffness as the parent joints. So though it has been seen that the strength is 50% of the parent joint, so you should construct your ideal rail joint in such a way that the strength will be similar to the parent joints. And the joints what you have provided, there should be a sufficient expansion gap need to be provided for the free expansion and the contraction of the rails, which may be caused due to the change in temperature. And the joints provided should be flexible for the easy replacement of the rails. And we have seen that the rail wears are common and under all normal operating conditions. So the joints what you have constructed, there should be an adequate provision for the wear of the rail ends. And the next, with respect to the elasticity, so the joints what you have constructed should have adequate elasticity as well as the resistance to the longitudinal forces, so as to ensure the trouble-free tracks. And last requirement is with respect to the cost. So the joints what has been constructed, the initial as well as the maintenance cost of an ideal joint should be the minimal. So these are all the some of the requirements to be fulfilled by the ideal joints. So next we'll look into the what are the various types of joints that are being provided in the rail section. So now that we have the three main classification, the first classification, we have the classification according to the position of the sleepers. So how the sleepers are placed with respect to the joints. So with respect to that, we have four type of joints: supported joints, suspended joints, bridge joints, and the base joints. The next classification is based upon the position of the joints, how the joints are provided. What is the position in which you have provided the joints? So with respect to that, there are two types of the joints: square or even joint, staggered or broken joint. And we have some other type of joints which is intended to serve certain functions, which includes the expansion joints, welded joints, and the insulated joints. So we'll study in detail what are all the functions of providing the various joints further. So now let us look into the classification of joints based upon the position of the sleeper. So here you need to observe where the sleeper is provided. So in this, the first type of joint is the supported joint. So as the name indicates, so look into the picture here. The sleepers or rails joints are supported directly over the sleeper. So joints will come exactly on the place where you are having the sleeper. So now why this has been provided like this? So when it was expected that with the help of the supporting joints, the wear and tear of the rails can be reduced since there is no cantilever action. So we'll look into that. What is that cantilever action in the next type of joint? So since there will not be any cantilever action here in the supported joints, so it is expected that the wear and tear of the rail can be minimized. But actually in the practice, so though the wear and tear can be minimized here, but in actual practice when the joints are provided directly over the sleepers, it tends to slightly increase the height of the rail end. As such, the run on the supported joint is normally hard, and there is also wear and tear of the sleeper is expected since the joints are provided directly over it, and the maintenance presents a quite a problematic here in the supported joints. And the next type of the joint is the suspended joint. So now here you can see here in the picture, these are all the places where we have these sleepers. So now this is the particular place where the joints have been provided to connect the two different lines. So as you can see here, the joint is slightly suspended beyond your railway sleeper. I mean to say that the end of the rails are suspended between the two sleeper, and some portion of the rail section is cantilevered at the joint. So what is the meaning of the cantilever? If any portion is taken beyond the support, that we call it as the cantilever. So this particular rail section is cantilevered beyond the support here. So what is the support? Support is nothing but the sleeper. It is cantilevered beyond the support. As a result of the cantilever action, the ballast packing under this supports tends to get loosened due to the hammering action of the moving train load. So, and this particular type of the joints is most commonly adopted in the railways worldwide, and also it has been popularly used in our Indian railway system also. The next type is the bridge joint. So the disadvantages what we had in the suspended joints that has been overcome here with the help of the bridge joint. So what was the disadvantages there? So the packing below the joint, ballast packing, that tends to get loosened because of the hammering action of the moving load. So that need to be reduced. So how that can be overcome? So now this bridge joint is similar to the suspended joint. We will have the joints suspended beyond the sleeper section, but two sleepers on either side of a bridge joints are connected by means of metal flat or the corrugated planes that is known as the bridge plate. So you can see here in the picture, so this is the bridge plate which is used to connect between the two sleepers. Either this can be a flat one or it can be also the curved in shape. Last type of the joint is the base joint. So base joint is similar to the bridge joints, with the only difference that the inner fish plates are of the bar type and the outer fish plate will be special angular type, in which horizontal legs are projected further to extend over the sleeper to be bolted on the bridge plate and the sleeper. So you can see here this portion is projected beyond that, so that you can provide the connection between the bridge plate and the sleepers. Since because of this complicated design, this particular type of joint has not been generally used. And the next type of joints is based upon the classification based upon the position of the joints, or how the joints are being placed on the two different opposite rail sections. So these are the two running face of the rail section. So now here, as you can see here in the picture, the joints are positioned exactly opposite to each other in the other rails. The next type of the joint is the staggered joint. So as you can see here in the picture, the joints are staggered in position. So this type of joints are can also be called as the broken joints, and this will be provided normally on the curved tracks, whereas the square or the even joints are provided on the straight track. The other type of the joints that have been provided to intend some of the functions, which includes the first one is the expansion joint. So why the expansion joints are provided? So these joints are provided to provide a provision for expansion and contraction, which will occur because of the change in temperature. So, and also by providing the expansion gas, you can avoid the defects in the rail, that is the buckling of the rails can be avoided. Next type of the joint is the welded joint. So we already know why the welded joints are provided. If you want to increase the length of the joints without any fish plates and the fish bolts, okay, without providing the joints, you can go for the welding your joint section. So these welded joints basically fulfill almost all the ideal requirement of a joints, and you can call this as a perfect joints. So two steel rails are welded so as to reduce the noise in the running train. But after 100 meters of the welded rail, one fish plate joints or need to be provided. That will be provided because to provide a sufficient expansion gap for the change in temperature. And also by reducing the number of fish plate joints, we can also save the wear on the tires of the wheels. So here the picture here we can see how the joints have been welded in the to connect two different rail sections. And the last type of the joints we can see is the insulated joints. So first we'll understand why the insulation is required in the track portion. So some of the track portion need to be monitored with the track circuit. What is this track circuit? So sometimes at the railway station, you need to identify on the track whether the rail is stationed or whether the train is stationed or not. You cannot come and see all the time. So now here we will provide a track circuit. So with the help of the track circuit, you can actually identify the presence of train on the tracks. Okay, so now when such track circuits are provided, there are chances that the current will run beyond this railway track, and that may cause certain danger. So now to avoid the running of your current beyond the track portion, we need to insulate the joints. The insulators are provided at the joint portion. Such joints where the insulators are provided, that we call it as the insulated joint. So what is the purpose? Insulating medium is inserted in the rail joint to stop the flow of current beyond the track circuited portion. So insulated joints are required to be installed especially on each track end part and also in the crossing section. So usually the dense polythene material bounded to a rail joint can provide a super insulations between the rail track and the rail joints. So these are all the some of the joints that need to be provided to connect the two different rail sections. With this, I'll conclude this session. Thank you.